All right, in today's lesson, we're going to be solving log equations that are quadratics. Now, yesterday, our equations, we condensed, we swirled, and we solved. But once we swirled, our equations were just linear equations. They were all just x to the first power. Even the more complicated ones ended up with x to the first power. Today, they are all going to end up being quadratic, or something with x squared. So it's going to require us to do factoring. So before I recap factoring and solving quadratics, I want to remind you, we can't take the logarithm of a negative number and we can't take the logarithm of 0 because this is the asymptote and the graph does not exist over on the left side of the graph. And so this is going to come back up today because as we're doing quadratics, we're going to have two answers. And we're going to have to check for extraneous solutions of those two answers. All right, and I'll show you how to do that when we get there. Now, how did we do quadratics? So when we solve a quadratic, we set the full thing equal to 0. We factor it, then we set each factor equal to 0 and solve for x, okay? That is one way we could do quadratics. The other way we could do quadratics is if it's something simple like this, you don't have to factor necessarily. You could move this over and set it equal to 4, take the square root. But when you do this, remember, when you take the square root and you take an odd number out, you have to do the absolute value. And it's the absolute value of 2, right? Or absolute value of x is 2, I'm sorry. And anytime there's an absolute value, that means it could be positive or negative 2. So you have to be aware of that, all right? You can use either method to solve quadratics. Whatever one makes sense. This one makes the most sense when there's only 2 terms. This one makes the most sense when there's 3, when you need to factor, okay? So let's try some practice questions on this, all right? So let's do number 1 here. All right, number 1, 2 times the log base 3 of x plus the log base 3 of 3. Now, I want to condense. Remember, that's the first step is to condense. So remember this 2 is a power on this x, right? I can put it as a power. And this means I'm going to be multiplying this times this. Now, I wouldn't write it as log base 3 of x squared times 3. I would just put 3x squared. That just makes more sense. Equals 3. Now we're at the point we can swirl. So let's swirl this out. So we'll have 3 to the third equals 3x squared. So 3 to the third, remember, is 3 times 3 times 3, which is 27. So I'm just going to scooch it over here and put my x on the left. Then I divide by 3. So x squared equals 9. Now this is one of those, I wouldn't do the whole factoring thing. I would just take the square root of both sides. But absolute value of x is always plus or minus. It could be 2 numbers, right? That means that x could equal positive 3 or x could equal negative 3. Now, before you just assume those are the 2 right answers, one of these might be extraneous, so we need to check. Let me show you how to check. The fact that it's negative doesn't mean it's extraneous. It just look at how it plugs in the equation and go back to the original equation. So if I take this positive 3 and I put it in here, it's still positive. So I'm still taking the logarithms of positive numbers. All is good. So we know that this one is a good answer. Now if I come back with a negative 3, this is asking me to do a log of negative 3. Well, that doesn't work. You can't do that. So because that's true, this is what we call extraneous solution. Okay? Now, again, I want to stress that just because it's negative doesn't make it extraneous, because sometimes you can put a negative in the equation and it becomes positive and you're taking the logarithm of positive, so all is good. But you need to always check. So these are quadratics, right? So you're going to have 2 answers, but you need to check both will work. Also, I wanted to point out to you that when you do a quadratic and you solve it like this, right here, you want to make sure you show all this work. Okay, and especially those of you who are going on to AP courses, because if you don't show this work, an AP grader can't give you credit. You have to show the work on why is there 2 solutions. Well, because it's an absolute value and they always have 2 solutions. You've got to show those steps to give full credit. So don't be lazy. Show the work. Take up the lines on your paper. It's fine. Let's try number 2. Log base 12 of x plus the log base 12 of x plus 1 equals 1. So the plus sign and the same basis means I can condense to log base 12 of x times x plus 1 equals 1. Now I can swirl. So if x times x plus 1 equals 12, right? 12 to the first power. Now if I distribute that out, I have x squared plus x equals 12. All right, now set it equal to 0. So we're going to move our 12 over. So I have x squared plus x minus 12 equals 0. Now we have a trinomial. Remember? That means we're probably going to factor. So we're going to multiply and add. So what are we multiplying? We're multiplying to get negative 12. We are adding to get a positive 1. Hopefully 4 and 3 come to mind. And I can use the shortcut on this one because that coefficient's a 1. So it's x plus 4, x minus 3. So when I set them equal to 0, this x is negative 4. X is 3. Now we go back and figure out, does this work? Can I put a negative 4 in here? Well, look, log base 12 of negative 4. That won't work right there. Right there it goes bad. So I know that this is not a good solution. What about the 3? Log base 12 of 3 will work. Log base 12 of 3 plus 1 or 4, it works fine. So this is my only good solution on number 2. Let's try one more. 2 times the log base 2 of x plus 3 equals the log base 2 of 4 plus 2. Now, I need to condense. That means I need to get this logarithm over here. So I'm going to have to cross the equal sign. So it's going to look like this. X plus 3 minus log base 2 of 4 equals 2. Now we can condense. There's a minus sign. So and it's a log base 2 something over something. So this 2 becomes a power. And the 4 goes on the bottom. All right, at this step, notice I have x plus 3 squared. That means I have to FOIL this. All right, I got to FOIL it. So it's going to look like this. Log base 2, when I FOIL this out, x squared plus 6x plus 9, maybe you need to do that in the margin, that's fine, equals 2. All right, from here, we're going to swirl. Now we swirl it out. So we're going to have 2 squared over 1 equals x squared plus 6x plus 9 over 4. Don't let that freak you out. Let's just keep going. What is 2 squared? It's 4. All right, now we have a proportion. So we're going to cross multiply. I'll have x squared plus 6x plus 9 equals 16. So I need to set it equal to 0, so I need to move my 16 over. So x squared plus 6x, 9 minus 16 is what? Negative 7 equals 0. Now we're at the factoring stage. It's a trinomial. So I'm multiplying to get a negative 7, and I'm adding to get a positive 6. So that looks like maybe a 7 and a 1, and the negative is on the 1. Can I use the shortcut? I can. So it's x plus 7, x minus 1. Then I set them equal to 0. So x is 1, x is negative 7. All right, now let's go back and check. Let's look at our original equation. Will this work? All right, let's look at our answers. So x is negative 7. If we go back to the original equation, put in a negative 7 here, well, negative 7 plus 3 makes it negative 4. So I'm still taking the logarithm of a negative. That means that this answer is not good. So you need to make sure you mark it as extraneous, not a good solution. Let's try number 1 though, x equals 1. So if I put in a positive 1 here, it's still 4, it's still positive. So we're good, so the 1 should work. There's no x on this side, so we're good to go. So x equals 1 is my only good solution here. Now, before we part ways, I just want to remind you that all the ones we've done today in the practice have been factorings where you can use the table, right? And you can use the shortcut. Yay, go team. But that doesn't mean they're all that way. You will see some that are factoring that you're going to have to do the grouping thing. So I want to remind you of the grouping. So let's practice the grouping just for fun. All right, so remember we have to group when that leading coefficient is something besides a1. So 3x squared plus x minus 4 equals 0. So when we do our multiply add chart, we're going to multiply to negative 12, but we need to add to a positive 1. So the two numbers that work are 4 and negative 3. They work, sure enough, but I cannot use the shortcut. So this is where I have to rewrite that middle term. So a 3x squared plus 4x minus 3x minus 4. All right. Now, if I group these, what can I take out? I can only take out an x, so I'll have 3x plus 4. These two, I bring down the minus, it follows me there, and I take out a negative 1. So put a negative 1 as a placeholder. That might help. And that would give me 3x plus 4. So then that would leave me with 3x plus 4 times x plus 1. And then you would set them equal to 0 and go from there, right? And you can continue solving. So don't forget how to factor with grouping, because you will need to be able to do that on your assignment as well. All right. Hopefully this makes sense. Thank you for listening and watching, and we will see you in class.